Okay, so we can make things look like they're in the quadratic form by substitution. If you see up here in the example, we have p to the 8th, but if I factor out a p squared, then I'm left with p to the 6th, which I could further pretend like instead of p to the 3rd, I could think about that being x squared, and in the meantime I'll just have x is equal to well, do I want to do a half? I don't think I want to do that, but I could represent it. I could just say it like this. I could say x squared is equal to p to the 3rd, and I could substitute it in later. I could do something like that. So anyhow, let's go ahead and see what we can do. We'll say we'll take a z. Oh, and we can take a 2 out of both of those as well, right? So we'll say 2z out of 32z to the 5th. That's 16z to the 4th. Minus, the 2z is gone, so I have a 1. Okay, now at this point I'm going to say my substitution is much easier than it would have been up there in the example. I'm going to just say that z squared is equal to x. Okay, so then I'm going to substitute that in. I'm going to say, I'm going to leave the 2z out of it for now, and I'm just going to focus on the 16 z to the 4th minus 1. And instead I'm going to say 16 x squared minus 1, and that's the same thing, right? And I suppose I could have done it with 16 as well, but I'm just going to say I can recognize this as the difference, since it's a subtraction. It's the difference of two perfect squares. These are both perfect squares. Okay, and I know what to do with the difference of two perfect squares. I'm going to say this. I'm going to say 4x plus 1 and 4x minus 1. The difference of two perfect squares, I can factor that by having the conjugate of the first, 4x plus 1. I get 4x minus 1, and there's no middle term. And so if I were to FOIL that or multiply that out, I'd get back to the same thing. And then I can substitute that back in, and I can say, we'll write, instead of saying 4x, we'll say 4z squared. We put it back in, plus 1. And I can't factor that, and I say 4 z squared minus 1, and while I'm at it, let me put the 2z back out there in front, 2z. That didn't affect anything on the inside. And then I say, wait a minute, there's still some work to be done here, because this is the difference of two squares again. So I can factor this into 2z squared, not z squared, sorry, 2z plus 1, same as I did before, and 2z minus 1. So if I can keep on factoring, I'll keep on factoring. And I'd say, okay, now I can write this all together. 2z times 4z squared plus 1, which is the sum of two perfect squares. And I can't factor that, but I could factor this difference over here. So here we go with the difference. And now I'm all done. Now I'm all done. And only now am I all done. Okay? So if I factor that out, or if I multiply that back out, I'd get back to where I started from. But this is in the factored form. And it would allow us to see certain things. We could solve for z. And let me just show you that real quick. Here out in front, if z is equal to 0, that's a solution. There's nothing I can put in here, so I'd get nothing here because I can't make that 0. Same thing, well, let's see, I was going to say same thing, but it's not true. if z were equal to negative 1/2, negative 1/2 times 2 is negative 1. So that's another solution. And then over here, if I said z was equal to positive 1/2, that's also another solution. Now, it didn't ask me for solutions, but you know that when we factor a polynomial, we're kind of thinking about solutions, because I may not be able to look at this up here and see what the solutions are. But once I have it factored, I sure can think about the solutions. Even if they didn't ask me for them, I'm still thinking about them. Because when I was gonna, if I were gonna graph this polynomial, I'd know it's gonna happen at 0. It's gonna cross the x-axis at 0. It's gonna cross the x-axis at half, and it's gonna cross the x-axis at minus half. And if I were gonna, if I were graphing something like this, what is this? Well, this is an odd function, right? So it's going somewhere, and it has a positive coefficient, right? Just to go back to the earlier problem. It's a positive, so it's coming from nothing, so it's going to go through here, it's going to go up and down, and then it's going to go like that. So I know this much about it. I know where it's crossing the x-axis. I know its basic behavior, that it's coming from nothing down here, and it's going to something, up on top here. So I know these things about it. I don't know how high exactly. I don't know how low it goes with the wiggle in between, but I know some things about this. Now, of course, it didn't ask for all that. It just asked me to factor it. But when we factor it, all these things are implied.